I've always wanted a drum set at home, but these traditional ones are noisy, bulky and take up way too much space, so I decided to create a compact desktop version of MIDI drums. That's how these drums came to life. Stick around and I'll show you exactly how I built them. I started simple with a standard piezo speaker. It's not just for sound, it can act as a sensor. When you hit it, it generates a small amount of electricity, which is what we need to detect a drum hit. The stronger the hit, the louder the drum will be. Let me show you how. There are various sizes of piezo speakers, and for this project I'll be using the largest ones I could find. They are 35mm in diameter. When I strike the piezo, it generates a small voltage spike. The Arduino reads that spike and can do anything, like send a MIDI message to the computer, where I have a MIDI program running, like Apple's GarageBand, or something more advanced like Ableton Live or Logic Pro. But since I am located in a garage, I'll be using Apple's GarageBand, of course. Here is a quick disclaimer. Certain Arduino models like Leonardo Pro and Pro Mini have the ATmega32U4 chip, allowing them to function as HID devices and to work as plug-and-play MIDI controllers. Other Arduino models can still be used, but they require a USB to MIDI bridge like Hairless. Next, I connected the piezo speaker to the Arduino as an analog sensor and wrote a simple code that registers that hit, measures the strength and determines which note and pitch to send to the computer. When I attach the piezo to a larger surface, it extends its sensing area, allowing hits to be registered across it. I designed this plate so I can glue the piezo directly underneath it, and the whole surface will become the drum itself. To keep all the plates in place, I'm using two mats. The first one holds the plates in place, and I've cut out pieces from the other one to place them underneath to absorb the impact of the hits. I 3D printed these templates to easily mark the circles where I'll place the plates inside. To attach the mat pieces to the plates, I'm using a universal glue commonly used for furniture or fixing shoes. I'm not completely certain it's the best choice, but it did the job and will stay flexible with the time. The tricky part is applying the glue to both surfaces and waiting for it to fully dry before pressing them together. For the underside of each drum, I'm cutting mat pieces with the same diameter as the plate to isolate it from the surface it is placed on. I attach this 3D printed piece to the opposite side of the piezo speaker to increase pressure when the drum is hit. On top of that, I glue the mat piece, completing the entire structure of the drum plate. Alright, let's give it a try, but before that I'm gonna need a pair of sticks to play with. Or maybe I could print them. Look at these sticks, they're just real ones. Let's give it a try. It sounds quite rough if you ask me. I've noticed it before, but now it's pretty obvious. Here's the problem. I'm getting multiple signals from a single hit. This reminds me of a common issue in web development where an impatient user clicks a button multiple times, leading to repeated submissions and potential data duplication. I'll handle it the same way I would do in web development, by debouncing the extra hits for a short period. The delay should be just brief enough to avoid missing any real hits while keeping the drum responsive. I've made some code adjustments, so let's see if the issue is resolved. Now I can clearly hear that it skips some hits. So the settings should be somewhere in the middle of the two positions. Okay, this sounds a lot more promising. Let's move forward with the rest of the project. I've assembled everything and now I place them to the right positions. The desk mat should fit into the slot. This is how I insert the plates into the mat, and then I apply hot glue to keep them in place. I've created a custom Arduino shield that follows this schematic. It uses almost all the analog pins, but they are just enough to cover all the drums without the need of any additional components. I realize the fact that I'm using way too much hot glue for this project, but check it out, the cables stick so well that the only way to remove them is to tear the mat, plus it stays flexible. Everything is wired up except these two cables that I'm saving for a bass drum pedal. And this last part completes the whole assembly. Are you ready to see the front face of the drums? Here they are. Here's my setup. I have the hi-hat, snare, high tom, mid tom, and low tom arranged here. On this side I've placed the right and crash cymbals, and the foot pedal triggers the bass drum. Alright, I've got the drums set up, but to do a proper demo I still need to learn how to play them.
Today I'm going to be teaching you how to play drums in only 10 minutes. The first step to learn this MIDI beat.
10 minutes later.